Hello everyone, welcome back. For this session, I couldn't be more excited to see you all as we are going to do machine learning implementation for the very first time. So if we take a look at our journey so far, we are presently doing a hands-on in Jupyter like a professional who knows every important detail about how the code works behind the scenes. Today, we are going to deviate our plans slightly. So in our last session, we have completed introduction to Jupyter and data visualization feature, and the next thing that we wanted to do was AWS sign up. However, from our last session, I felt that it would be more worthful if we complete the Jupyter notebook lesson with a hands-on experience on a machine learning use case. So for now, we will park our task for AWS sign up for the next lesson, and in this we will have a look at the developer's world with our first end-to-end use case in machine learning. So let's do machine learning. In our last session, we saw how to perform data visualization using Jupyter, and we plotted this dataset in our Jupyter notebook. We had the actual value of x and y, and we simply plotted it using Python package. However, what happens when we want to plot the value of y based on the current trend on the values of x? Let's say, what will be the value of y when x is 6 or when x is 7? Now we do not have the real values of 6 and 7 for x and y, and this is what we want to predict. If we are able to predict the value of y based on the current trend, then that's basically learning from existing data. And guess who is learning here? The program or the machine itself. If we have a program that can learn from existing data's trend to predict future values, then that's exactly what is called as machine learning. Let the machine learn like how humans learn from experience. And what happens when humans learn from their experiences? They become intelligent, naturally intelligent. Same way, what will happen when we have a program or a machine that can learn from experiences that are stored as data? They become artificially intelligent. So, I hope that I'm able to convey the idea that how this small concept of predicting the value of y based on the trend is connecting to artificial intelligence, and we all know that how this small idea has eventually turned out so big today that it is taking the form of generative AI. We are heading in the direction of generative AI, so sit tight. And for now, let's get back to our example. Now, based on our existing trend, we want to know the value of y based on the value of x. When x is 6, then what will be the value of y? Will it be this? Will it be this? Or will it be this? Similarly, what could be the value when x is 7? So basically, we want to identify the existing trend to predict the future. Same time, we want our program to be generic enough so that it is not hardwired to the exact patterns. Instead, we want a close and rough estimation of the trend to keep the intelligence intact. If we code the program to follow the exact data points, then the program will lose its intelligence and it will become any other software which doesn't have any intelligence. It is just a set of if-else conditions. So instead of fitting a curve exactly, we will fit a line that matches the trend most closely. It can be a line like this, or this, or it can be a line like this. We will try to have a program that can identify a line that matches the curve most closely but not exactly. And fitting a line to a curve is called as linear regression. Let's welcome our dear friend, the jargon dragon, which has brought the jargon, linear, and regression to us. As they say, what's in the name? But I believe that in today's world, there is a lot in the name, and it gives us a lot of insight to understand why a concept is named something specifically, like why it is called linear regression. So let's break down the jargon linear regression. As we can see that the jargon has two terms into it. One is linear and second one is regression. So linear in a very simple term is related to the concept of a line. We can also see that the word linear itself has line into it. It generally refers to anything which is straight or follows a path. Now in our example, if we relate, we are trying to find a path which is generally being followed by our actual data points. And when we talk about the second term, which is regression, in general, regression means the act of returning to a previous state. So we are trying to determine the state of our y variable. And when we talk about statistic, then it means that we are trying to develop a relationship between our dependent and independent variable. Now two more jargons again, dependent variable and independent variable. So when we were plotting our graph, that time we had some values on the x-axis and some values on the y-axis. As we can see that the values of y were derived from the values of x. If x is 1, then y was some other value. X is 2, then y was some other values. So what we can see that the values of x are not dependent on the values of y, which means that whatever values that we plot on the x-axis becomes our independent variable. It is independent of whatever value that y is going to have. So the independent variable will always be on the x-axis. It is independent. And whatever is plotted on the y-axis is our dependent variable. It is depending on the value of x. So let's try to connect it with an example. Let's say we have two variables, let's say age and salary. Now, if we think about age and salary, probably the age will be a continuous variable which is always going to increase. It doesn't matter whether a particular age has a salary or not. If there is a person with a specific age, he may or may not have salary, right? So if we talk only about these two variables, salary and age, the age will continuously be increasing irrespective of whether there is a salary, whether it is increasing, whether it is decreasing or not. Now, if we have to think out of age and salary, which one is our independent variable, then obviously age becomes the independent variable because age does not depend on salary. Other way, the salary depends on age, which means that if we have to plot age and salary on a graph, our independent variable age has to be plotted on the x-axis and the dependent variable y will be plotted on the y-axis. Alright, so we have a general understanding of the jargons that are needed to get us started with linear regression. We understand what is linear, what is regression, what is an independent variable, and what is an dependent variable. And with this, we are absolutely ready to get into our lab. But before we get into our lab, let's fly away our dear friend Jargon Dragon one more time. These jargons, linear regression, do not scare us anymore. Let's head to our garage and step our feet into the machine learning world. See you in the garage, everyone. Alright, let's go to the start menu and let's start our Jupyter notebook. Okay, so this is our home page of the Jupyter notebook. If you remember from our last session, this project directory, project 1, project 2, etc. has been created in our Windows Explorer as well. So we have redirected our Jupyter server notebook to the directory called as My Data Science Projects. The directories that we see here, which is project 1, project 2 and project data visualization, is the same thing that we are seeing here. Okay, so let's, and the reason we keep switching between Windows Explorer and Jupyter server is we need to have a cleaner structure, and we want to make sure that whatever we are doing, we know that where these files are getting stored. Okay, so let's start with by creating a directory called linear regression. And when we create the directory, you will observe that Jupyter server will refresh on its own, and the directory that we create in Windows Explorer will be populated in this list as well. Let's see. All right, new, let's call it linear regression. You can have spaces in the directory name. I generally prefer not having any. All right, so linear regression is our directory. We can see that the directory structure is like lowercase. Let's change it. Let's call it linear regression, just to keep the name syntax same. All right, we can see the directory is created. We go here, we will create a notebook inside that, and initially it is going to get called by untitled. Let's select the kernel. Let's rename the notebook. Let's call it my first machine learning program or notebook. My first ML notebook. Okay, all right, and very quickly if we go here, we can see our notebook is here. Now let's get started with where we were, and what exactly we are planning to implement. So we are trying to understand that for a set of values which is 1, 2, 3, 4, 5 and their respective y values, which we have plotted on the graph, what will be the next value for x equal to 6, or what will be the next value when x is equal to 7. So for this curve, we want to develop a Python notebook and identify a line which closely matches the curve. So let's get back to the notebook and we will plot the values of x and y first. Okay, let's give a nice title to our notebook. We are going to change this cell from code to markdown, and let's call it with a hash sign 10,000 feet developers world. This, now we are working as a developer, so let's call it developer world first end to end ML program. All right, so this gives a nice title to our notebook. Next thing, let's quickly redefine our objective. So we are going to now have, let's say, two hash sign objective. So these are good practices when we are developing the notebook. So whenever you are revisiting your notebook again in future, or if someone else is looking at your notebook, then they should know that what has been done in this notebook. So it's always a good idea to mention. So let's call it, let's say, based on below actual values of x and y, learn the data trend, let's call it, and predict the value for x equal to 6 and x equal to 7. So our values for x is 1 comma 2 comma 2 comma 3 comma 4 comma 5, and the actual values that we already know is, let's say, 1 4 7. These are just sample values to understand the concept. 23. Okay, if I just put a shift enter, it will run the cell and it will create a new cell as well. Now the next thing that we want to do is, let's plot these x and y values in using a pyplot library. So let's plot the values of x and y. So now we are going to create a data structure. Let's call a Python list. Python list is always created with a square bracket. So inside the square bracket, we will put the values 1, 2, 3, 4, 5, and let's create a list for the y values, which will be, let me copy this, it will be quicker, 1, 4, 7, 13. Okay, and we can always print type of x. It's always good sometimes to know that what is the value of your, or what is the type of your variable. All right, and if I run this, okay, there is a comma missing. If I run this, then it says that type of x is a list and type of y is also a list. Let's import the library that we need. So it will be inside matplotlib.pyplot, and let's give it an alias. Let's call it plt. Okay, and it's very simple to plot. Let's call it plt.plot. Plot the values of x and y, and let's call the label, let's give some label as actual values. Let's call it actual values because we know. Let's assign some color to it, which is, let's say, blue, and let's assign a marker to it as well. Let's call it dot. Dot is represented as O. Okay, and let me run the cell. All right, it might take few seconds to plot. It is going to import the library, and we can see it here that it has imported. Right, let me actually make it a full screen. Okay, this is better. All right, so we can see that for the values of x and y, we have plotted the line. When x is 1, then y was 1. When x is 2, then y is roughly, not roughly, exactly 4. X is 3, then y was 7. We can see it. So actually we can plot this as well, the labels, but we are now learning linear regression or machine learning. There are a lot of variation that you can do in this plot, and we will try to keep our discussion oriented towards linear regression. But yes, there are a lot of data visualization variation as a data scientist when you work in a real world. We'll try to cover that as a separate lesson as well. Okay, so we can see that the values has been plotted till x equal to 5. That's what we have mentioned when plotting the graph as well. And we want to know the values when x is 6 or x is 7, right? So let's put some arbitrary future values and see if we are able to mimic this particular picture in the notebook or not. So for that, I will just assume some arbitrary value for x equal to 6, which is, let's say this is roughly 18, maybe 20, between 20 and 25, and this is over 25. So I will just assign some arbitrary 3 values when x is 6 and arbitrary 5 values when x is 7. And we will try to plot this picture into our notebook. So let's create a new variable called x underscore future and assign it the list values. So how many values are we looking to plot? 3 values for 6 and 1, 2, 3, 4, 5 values for 7. So let's create x equal to 6 because we are plotting the same x 3 times. So that's why x is 6, 6, 6 3 times, and then 7 5 times. 1, 2, 3, 4, 5. Okay, and let's assign some arbitrary value for now, just for depiction purpose. to y as well. So we have the values of x and x future and y future. These are just arbitrary value. We are nowhere saying that x will have a value of 18, 24 or 27. We just don't know. So we are just plotting this as of now before we find out the most matching line. So let me copy this line. This is my plot for the actual values of x and y, and the next values for this will be, let's call it x underscore future. Let's plot the x underscore future and y underscore future, right? Let's remove the label for the moment, don't need it. And just to differentiate between the colors, let's call this as gray, and let's give a different marker to it as well. And now if I run the cell, all right, 2 commas, so let's see what values are getting plotted, how it is getting plotted. So we can see that it's getting plotted with a line, but the idea here is we want to have it something like this, right? So instead of creating a line plot, we can change this future value to a scatter plot. Let's plot it again. All right. So this is something similar to what we are trying to do. A line, a curve, which is the actual values. Then for x equal to 6, we want to understand whether it is this value, this value, this value, or something else. So we are going to identify this line with the help of a machine learning algorithm. And before we find the best matching line, let's provide some wild prediction. Let's assume that this line is going to be like this, or it might go down. So let's put our hands dirty with some of the data visualization techniques. So what we are going to do is we are going to make 4 wild predictions, just wild prediction. We just don't know what are the values for x equal to 6 and 7, but we will just assign 4 different type of wild predictions, and we will plot it into a single cell as well. Now why we are doing this? We are doing this to understand how we can plot multiple graphs using a same cell as well. This has nothing to do with linear regression. This has more to do with data visualization. So when you will be working as a data scientist, then you will have to plot a lot of graph. So we are just practicing a little bit more on data visualization part. Okay, so let's make some wild predictions. Okay, and we are going to make 4 predictions. The reason we keep doing this type of activities is we want to build our mindset as a professional. We just do not want ourselves to be okay, here is the values of x and y, here is the program that you run for machine learning, and then here is the predicted value. No, we want actually ourselves to think out of the box, think what are the different possibilities, because when you will be working in a real business world, then this theoretical knowledge or simple notebooks, straightforward notebooks, is not going to help you. Instead, your mindset will help you. So that's what we are trying to build here. Okay, so what we will do is, we know that the value of x and y, actual values of x and y is this. Okay, just for the sake of clarity, we'll just put it again, right? And then I'm going to call, let's say, x underscore wild prediction pred1 as an example, and I will plot the values of x equal to 5 we know the actual value, 6 is I'm going to make some prediction, and 7 I'm going to make some prediction. Let's copy this and paste this, and let's call it y prediction. For the value of 5, we know that the actual value is 23. For 6, what we will do is, let's put something, let's put a squared value, 36, and square of 7 is 14. And this is just my wild prediction that for 6, the future value will be 36 and 7 will be 49. This is, as we keep saying, it is a wild prediction, anyone's guess, right? Let's assign some another set of prediction for 5, 6, 7, and this time let's assign the value of that, the value of y will be, let's say, 42 and 51, some values, right? Any, you can put any values and give one more prediction. We'll give two more prediction actually. This is the third prediction for 5, 6, 7. Our values will be, let's say, 10 times of the x values. You can put any formula that you want, or you can not even put any formula. Whatever values you want to assign, just assign it. Okay. This scroll is getting at the bottom of screen. So what I will do, I'll press escape, and with the button B for below, I'll just put some cell. Okay, some blank cells. So we have this in the middle of the screen. Okay, let's put our fourth and last set of wild prediction, that our values will be, let's say, let's call it 20 and 68, whatever, right? So what are we doing actually? We are making wild predictions that for 6 and 7 our value will be this, some other friend says that it will be this and this. These are all wild prediction, but let's plot all of this wild prediction in one cell. Okay, ready? So earlier we have seen that when we want to plot the values of x and y, we are simply taking the value of x and y and we are plotting it. So this plots one graph, but what we want is, we want to plot 4 graphs next to each other, 1, 2, 3 and 4. So the very first thing that you will have to do is, we basically are creating subplots. So the way to create a subplot is, let's call it figure, some variable, you can give any name, access, and we are going to call plt dot subplots. So we are saying that we are going to create subplots of size 2 by 2, 2 in the top row, 2 in the bottom row, and we can also assign, let's say, a size to each plot. So we are going to call fixed size as, let's say, 12,6, any size that you like, right? So with this line of code, we have mentioned that we intend to make 4 subplots, 2 in the top, 2 in the bottom. Okay, the very first plot, so access is, the very first plot will be 0, 0, and we are going to say plot plot. So instead of doing a plt dot plot, this time we are plotting it on an axis. Okay, and the method is very simple. Rest of the stuff is where we will copy this and we'll paste it here. So instead of plt dot plot, we are plotting it on a axis. And what we will do, on axis, this is the actual values of x and y. On the same axis, we will plot the future wild predictions, our wild prediction. So we'll just say axis dot plot, and instead of x and y, now we are going to call wild pred 1 and wild pred 1, y of wild pred 1, y of wild pred 2, and then let's give some type of different marking. So one of the parameter is, let's say, line style. We want to put a dash line style. Let's call it line style is dash dash, and let's give it a label as wild pred 01. Okay, let's give it a color of maybe gray and a marker of x. Okay, label, let me correct the spelling. So this is our label, and what we will do, we will also assign something called as the title to the plot. So this is all type of decoration that you will need when you work as a data scientist. Okay, our wild prediction, and let's call it 01, and then we'll plot the legends as well. Legends means basically will plot this labels on the plot. So for that we have to call a method called legend, right? So this is our first plot which we have plotted. Similarly, what we will do is we will plot the second. This time excess of 0 0 will change to 0 1. So on the first quadrant we are going to plot. Instead of plotting the while prediction of 1, we are now going to plot the while prediction of 2. Line style will keep same. Label, let's call it while prediction 0 2 gray. Let's change the title to 2, and similarly let's plot it one more time. Instead of 0 1, now it changes to obviously 1 comma 0. Okay, so this is our third subplot at 1 comma 0, and here we'll plot our third wild prediction. Okay, okay, and okay, and finally we'll plot the last excess. So here we will call it 1 comma 1. This is our fourth plot. This is in the fourth quadrant. 4 while prediction 4, and title is also 4. Okay, now since we are going to plot 4 subplots into one, so we want to keep things cleaner. So one of the method that we need to call is something called as type layout. This is just to put in a cleaner visualization, and finally we will call plt dot show. Okay, ready for the magic? Let me scroll it out, zoom it out a little bit, and let's see. All right, plot is not defined. Okay, so instead of this we have to call plt. Ready for the magic, and hope it works this time. Text object is not callable. Okay, okay, so actually this method is called as set title, not title. Let's change it. Set title, set title, again set title, and set title. Let's see if it works. All right, this is beautiful, right? So we have all the 4 predictions all over here. Let me zoom it in and let's see it. All right, so these are our wild predictions, right? That we are saying that X will have the value of this and this in our first prediction, or this and this and this, or instead we are saying that after 5 the value of X will dip and then it will go up. So these are all wild predictions. This is the type of data visualization that we will have to plot in the future as well when you are working on more complex machine learning use case. Now moving on, out of these 4 wild prediction, we want to identify the best line that will fit to our actual curve. So the blue line is our actual values and gray is our predicted values, and these predictions are wild. We do not want to make wild prediction, we want to make calculated prediction, and making calculated prediction is exactly what machine learning is. So we are going to find the best fit line for our actual values, and that best fit line can be found by using an algorithm called as linear regression. We have seen just few minutes ago that why it is called linear regression. Okay, so what we are going to do is we are going to import a package from a library called sklearn dot linear model, and we are going to say import linear regression. Okay, let's see if we are able to import it or not. And it might take some time because we are importing the library for the first time, and we have made a mistake. Actually it is called as linear regression with camel casing. Let's see. All right, this is executed. Whenever the cell is executed it will have a value, right? Next thing that we will do is we'll create a variable. Model is equal to linear regression. And if we just run it, then you will create a variable called model. Now what actually we have done, let's take a moment to understand this, right? When I was starting my machine learning journey some years back, then at that time I was introduced to the concept of linear regression, that okay, you import the package, you create the variable and do rest of the stuff, and I was amazed by the fact that what exactly I am doing, right? I created the notebook, but at the end of creating the notebook I do not even know what exactly I have done or why I have done, right? So that why part we will try to answer, and that's why we keep going a little slow, because we want to be fundamentally clear of everything that we are doing. Now, what we exactly have done here, we have imported a package called linear regression and we have created a variable called model. What does it actually mean? Linear regression is a Python code which is stored somewhere in our Python installation. When we installed Anaconda, then at that time a lot of utility packages has been already deployed or already installed for our usage. One of that package is linear regression. Now that package is simply a Python code. That package knows that how to fit a line. What it doesn't know is what is our data. It doesn't know that our data has 5 data points and their respective x and y values are this. So what we have created at this time is a plain vanilla linear regression variable. If we type the value of our variable and let's see, so it says it's a linear regression variable. It doesn't know anything about our data. So we are going to pass our data to this blank plain vanilla model variable. Okay, so what we are going to do is we are going to provide data to our model variable. Now one thing that we have to make a change here is, as of now our variable is like this, our data is like this. Let's print x. Okay, so it's a list, but the requirement by the linear regression algorithm is the data has to be in this format, like it should be a list of list, the first element, second element, whatever elements we have. So it's a list of lists. This is the requirement by the linear regression algorithm. Okay, so what we will have to do is somehow we will have to convert our data from a plain list to a list of list. And okay, so this is what we want. Okay, so the way we are going to convert our list into a list of list is by using a very popular library in Python, which is called as numpy as, let's call it np, right? And we will call a method called as numpy dot reshape. So let's call it x underscore, let's call it 2d variable or 2d list. X underscore 2d is equal to np dot reshape of x, and our reshape will have a total of 5 variables and it should be a 1d array. Let's see if it works or not. Let me print x of 2d. All right, so this is in the format of list of list, which will be required by our linear regression algorithm. Similarly, let's convert our y variable as well, y label as well rather. Okay, this is y, and we are going to convert this as well into a list of list. Print y underscore 2d. Why we are doing that? Because this is a requirement by the linear regression library that we are going to use. The linear regression does not accept a list, instead it accepts a list of list. Okay, now that we have our data in the format that is required, let's fit our data to the model. So we are going to call model.fit x underscore 2d and y underscore 2d. So we are asking the model variable to fit on our data. Now our model knows that how is our data and what is the best line fit for it. What is our data in the graph and what line it has identified, right? So it now knows what line it has identified. So based on that, let's provide the value of x equal to 6 and 7 to the model, and let's see what are the predictions. So let's call a new variable x underscore future underscore 2d, and let's assign the values of 6 and 7. These are the two values that we are asking the model to predict. And we will say y underscore future underscore 2d is equal to model dot predict. Hey model, please predict the values for us. Which values we want the model to predict? The future values. All right. So when we execute this, now we have the future values in our y future 2d. Let's print it. Y future 2d. Let's see what our model is saying. So our model says that for x equal to 6 and 7, and based on your current trend, the value should be 27 and 32.6 respectively, right? What we will do is we will actually try to plot this whole thing in our notebook so that we can see that how is our actual data, how is the predicted trend, and what are the future values. So let's do it. What we will do first thing is we will ask the model to predict the trend for our existing data. So let me create a variable called y predicted trend equal to model dot predict x underscore 2d. Now observe that x underscore 2d or x is actually our actual values, for which we already know the y values, actual y values. For each of these x actual values, we already know what is the respective y value. But we are asking the model that whatever line you have fit, if we ask you again that for the actual values of x, what would you have predicted? So we are storing those predicted value in a variable called y predicted trend. Okay, and then let's plot all of this together. So once it is plotted, it will be very clear why we created this y predicted trend variable. So let's call it color equal to blue, marker is O, and plt dot plot our actual value x underscore 2d, y print our predicted trend. Let's give it a line style of dash just to make a difference between the actual and predicted line. Line style is, let's say, dash dash. Let's assign it a color of gray, and let's assign it a marker of x or cross basically, right? And finally, let's scatter our plot for the future values. Plt dot scatter our future values x underscore future underscore 2d and y underscore future underscore 2d. Let's plot it in the color of red and again assign it the marker of x. Let's see. Okay, predicted trend is not defined. Did we miss the spelling? Oh, did we not? Oh, we did not define it. Now here is another learning for us. Whenever you see a square, whenever you see a cell with a square bracket and no number into it, which means that we did write the code but we did not execute it. As soon as I execute, it will assign the execution number for it. Okay, it says 66, some number, and then okay, let's see our graph. Oh, this looks far nice. So what it says is the blue line is our actual values and actual curve, and the line that our model has fit is the gray line. Now if you can observe, this gray line is very much in the direction, in fact it's actually in the direction of plotting the values for our future 6 and 7. So here you can see that for our actual values, with the help of linear regression algorithm, how we were able to identify the best line, and we are also able to predict the value of 6 and 7. Not only that, if you want, you can always predict the value of something a lot higher value. Let's say model dot predict, give me the value when x will be equal to, let's say, 500, right? So it says that when x will be 500, then the value of y will be 2793 based on the current trend. So that is the power of linear regression, that based on some sample values, you can predict the line, you can identify the best fit line, and once the line is identified, all you have to do is put in whatever x value you want, and you can keep getting the future values of y, right? So this is where a developer's job is complete, that he has prepared a model and that model is able to predict the values. But we are not here just to be a developer. We are here to be a complete AI professional who knows the end-to-end journey of how to get a requirement, convert it into a Python program, and then eventually develop it as an end product. This is just a piece of code. We cannot give this piece of code to our end users or even to our business users as well. So this is where we will be changing our view from developers world to a professionals world. Let's step into the professionals world now. So let's carry on our journey and let's deploy the package. Let me change the cell to markdown. Let's deploy the package with the help of a standard library which is called as joblib. Import joblib, and we will just say joblib dot dump. Dump means create our deployment file for our model, and let's call it say my fitted model dot pkl. Pkl stands for pickle. So when I run this particular command, what we will observe is in our directory there will be a new file that will be created which is called as my fitted model dot pkl. That is our deployed code. You can also observe in our Jupyter server, we will see the same thing here in our server screen as well. Let's see it one by one. All right, my fitted model.pkl. Let's confirm in our node Windows Explorer. We have the deployed code, deployable code, and we also see it here as well. So which means that as a developer, now I have deployed the code. It is up to my deployment team to pick up this code and use whatever way they want. If they have a web application, they can use this particular pickle file and use it into the web application. So now let's change our role from being a developer to being a deployer. We are going to deploy this model. Okay. So for that, basically what we want is we want to make use of this deployed model in a screen where end user should be able to input the value of x and get a respective value of y. We do not want end user to input the value in this Jupyter notebook. So for that, what we are going to do is we are going to create, let's say, a new Python file this time instead of a notebook to create our user interface. So let's create a Python file. The file name is untitled.py. Let's call it my integrated GUI.py. Okay. So this is the file that we are going to use to create our graphical user interface. Now think of it, we are no more developer, we are a deployer now. Our development team has given us a file which is called as the pickle file, right? The deployed model. We have to make use of this deployed file and build a GUI on top of it. So what we want is we want to load the model in our code, and once the model is loaded, we want to predict the values. Okay, so what are the logical steps that we are trying to do here? First thing is our developers has provided us a model. So in this file, we want to load the stored or load the stored model that is provided by the development team. This is our first objective. Second, let's say build a simple GUI, graphical user interface, where end user can enter the value of x and get a get the value or get the predicted value of y as response. So these are our two objectives in this. Okay, let's get started. For the first thing, load the stored model that is provided by the development team. We are going to import a library called as import joblib, and to load the model, let's call it loaded model. Let's create a variable. Loaded model is equal to joblib dot load, and inside joblib dot load we will have to pass the name of the stored model. What is the name of our stored model? Either we can take it from here .pickle file, or we can take it from our Windows Explorer as well. Let me copy the name so that we don't do any typo, and let's go back to this. Okay, and let's print the value that model loaded. So the way we are going to execute the Python program is we can go to the home screen and we can create something called as a terminal. A terminal is very similar to a command prompt, and from here, at this point, we are currently into the admin or the home directory of this. For us to execute the Python file that we are creating, this Python file we are creating, we need to get into our directory. So we will do cd. Let me increase the font. Okay, cd to our directory, and then we can always do dir to see if we are able to see the file. Yes, here it is, our myintegrated.py. Okay, let me do one thing. Let me take it into a separate window so that whatever we are writing is not at the bottom of screen. Give me a second. All right, I hope you are able to see the screen in the center. All right, so here we will write Python myintegrated.py. You can press the tab and then you just hit the enter. So now this is trying to run and it says model loaded. Now there is one learning that we need to do here. Let me clear the screen first and let me print the current path. So our current path is S data science, my data science project, linear regression, and we can see that our model is also present in the same directory. When we are working in a real world environment, then the model will be present in some other directory in a GitHub or some other place. So we will try to mimic that situation. Let's assume that my model that I stored it here, instead of it being present, my development team has put this model into, let's say, called linear, in a folder called linear regression underscore deployments. Okay, this is the folder where my stored model is provided by the development team, right? I do not have access to the development folder. I have only access to the deployments folder. Now what will happen if I try to run this Python file again? Python my integrated code.py, most probably it will give an error as expected. Okay, so what it is saying? It is saying that the file does not exist. Somewhere it show, yeah, file not found, right? Because our current directory is linear regression and the code is trying to find the stored model or the pickle file in the same directory only. So the thing that we have to learn here is, because we are we are moving our role from developer to a deployer or a developer to a professional, we are not always going to get the pickle model or stored model in the same directory. It will be in some or the other directory. We will have to pull that directory into our code. Now, as of now, that directory is called as linear regression deployments directory. So what we will have to do, we will have to go to our Python code, and currently this code is running from the linear regressions directory. So what we will have to see, load the model from dot dot. Dot dot means go one directory up, then inside that directory you will find the directory called linear regression deployments. Copy this, and then slash inside that linear regression deployment you will find our pickle file. Let's see if it works or not. There is a, because we are going to use slash, so we do not want to consider or let the compiler treat this slash as an escape character. So we will have to escape the slash with a symbol at the start of string which is called as R. R stands for raw. So this will should not create a problem. Let me save the file and let me go to the terminal one more time, and inside the terminal we will run the file again. Let's see if it works this time or not. Alright, now we can see that the model is loaded. That means our code has been able to navigate to the directory that we want. In future, this directory will be something else. Sometimes you will be doing a git pull as well, right? So all of that professional things we are going to see in our next sessions when we keep improving ourselves as a professional, right? Now, continuing with this journey, we have our model loaded here. The next thing that we want to do is build a simple GUI where end user can enter the value of X and get a value of Y. One of the simplest library that Python provides that is available in Python is called as Streamlit to create GUI. Import Streamlit as, let's call it ST. Okay. This is the library that we will be using to create our GUI. Now there are few simple things that we can do. Let's say set the title of the app or screen, whatever you want to call. So the way you are going to do is st dot title and whatever string or name that you want to give. Let's call it my first ML program, right? The next thing you might want to do is we want to take some input from the user, which is the value of X, right? So let's again, let me just take it out so that we see the code at the center of the screen. Let's maybe this. Okay, so the next thing that we want to do is create an object to take input from user. The way to do it is st dot text input, and we will just say text as enter value for X. You know what, this X and Y, you can consider them as some variables, age and salary as an example. X is your age and Y is the salary. So let's say based on your age or based on the age of an employee, we want to predict what salary he or she might have, right? Now let's store this age into a variable called user input, whatever you want to give the name, right? So now we have got the input from the user. The next thing that we want to do is we want to call the model when the user submits the button, right? So we are going to create a button, right, so that user can submit it. We are going to call it st.button and we are going to call it submit. If st.button is submit, then the code that we want to do is read user input is equal to int of user input. We are just making sure that if user is entering some values which is not an integer, we are just converting it to integer. Then as because our model accept the values only in 2D format, so we will have to reshape our value of X into a 2D format. So we are going to call it user input underscore 2D is equal to, now np, did we import the numpy library? We haven't imported the numpy library, so let me import it. Import numpy as np. Okay, and the method that we are going to call is np dot reshape, and reshape the value of user input in an array of 1 comma 1. Okay, once we have the value of user input in a 2D array, we are now absolutely ready to call the prediction. Prediction is equal to loaded model dot predict, model dot predict basically, and then let's pass the value of user input 2D. We will get the value back into prediction, and finally we will write st dot write, and it will be, let's say you entered, and we'll just print whatever user entered, user underscore input. Let's print the value of prediction as well, which is, let's call it predicted value is our prediction. Okay, we will save the file and we will switch back to our terminal now. Let me close the windows. Okay, we are back to our terminal, and the way to run a Streamlit application is by the command streamlit run. Streamlit run, and then the file name my integrated GUI.py. Let's see if it runs. All right, it's in gray, but you can see that it says that the Streamlit application has executed. It has also opened a window for us. We are good to maximize it. My first ML program, this is exactly what we have written in our title. My first ML program. User input, it is taking enter the value of x, that we can see it here. Enter the value of x. It has created an input box for us, and it has also created a button for us, right? So let's enter the value of x as 25. Let's see what its salary should be, or the value of y should be. All right, so it says that you entered 25, predicted is 133.14 is the value of y. So whatever value that we are putting here, now the values are coming back from our model. You can put whatever values you want. Let's put a value of 44. Let's hit it. Model is loading, and then we should get the response. Okay, model has loaded. The value of 44 is 239. So when x is 44, the value of y should be 239. Then you can do all sort of formatting that you want, right? So with this, let me congratulate you that we have completed the developer's world. We have also completed the professional's world, which means that we have all the basic knowledge that is needed by us to jump into the cloud world. So in the next session, we are going to step into the cloud world, where we are going to do the AWS sign up. We are also going to do machine learning in AWS SageMaker, which is the machine learning environment, integrated development environment, which is provided by AWS. This journey is already very interesting. So see you everyone in the next session.